Good afternoon, everyone, and welcome to the Airfield Markings webinar presented by Professional Pavement Products, PPP Transportation Safety Innovations. And a special guest host is Sightline. And today's webinar, we're going to go for 9 segments. One is just a little bit of introductions, who we are, who I am, Mike, maybe a little bit about our companies, but also we're going to go over what our objectives are on this webinar. And then the FAA Airfield markings, the new standards that were released in December of 2018. We're going to discuss marking visibility factors, the top 3 marking defects, methods of assessment. As a little bonus, we're going to provide some good data, good information as a result of a 2-year case study with JAX, that's Jacksonville International Airport. And also we'll talk briefly about best practices and some cost savings. Our objectives today is to inform, educate, and assist. We're going to do this by expertly reviewing and clarifying the new FAA language on the maintenance requirements for pavement markings in the airfield. Also, we'll illustrate and explain airfield markings' 3 most common failures and their causes. And we're going to update you on some new assessment technology and capabilities. In the end, we hope that to have you prepared for your next certification safety inspection and their new expectations. Also, to select a cost-effective method and tool for your assessment and inspection, and ultimately to make your airfield safer for pilots, passengers, and your peers. So first, introductions. My name is Greg Driskell. I'm the president and founder of PPP, Transportation Safety Innovations. I have 28 years of industry as an industry veteran in the pavement marking side of things. I am an expert in pavement marking materials, applications, and assessment. I'm a member of American Traffic Safety Services Association. This is where the pavement marking contractors and those that are stakeholders in pavement markings reside and are members of. I am the national chairman-elect. I'm also on the National Pavement Marking Committee and head up its advancement subcommittee. Also, I am on the Airfield Marking Training Oversight Committee. And then we go over to Mike Speidel. Mike Speidel is with Sightline, and he is a 14-year industry veteran, an expert in airfield markings, materials, application, assessment. Many of you already know him and have probably met him a time or two. He is also on the Airfield Marking Training Oversight Committee as well. So we're going to start out our presentation today with Mike, and he will first go over the FAA changes. Mike, I'll hand it over to you.
Yeah, thanks, Greg. Good afternoon, everybody. First, before we get into this, I just want to say thanks, everybody, for taking time out of their busy day, joining Greg and I for this webinar. Some big changes happened over the last 3 months, and really they've been kind of coming down the pipe here for the last year or more. The change that we are referring to, or the changes that we're referring to, happened in December within the 5370-10. We'll kind of take a real quick, brief overview of just the changes that affected markings, airfield markings, and specifically the new maintenance criteria that has been defined for Part 139 airports. So I think, speaking in general about the entire document, and speaking to the authors, their revisions were really focused on improving quality and the product that resulted from these projects. Some of the things, just a couple highlights that I wanted to throw in here that were added, were daily calibration of equipment. The FAA is really focused on getting these applications to be their best, and doing continuous inspection, having a good QC or QA program in place during application. And then finally, they define this maintenance criteria, and we'll look at that piece, this newly defined maintenance criteria in detail here in the next couple slides. So you guys are probably familiar with the probably the 5340, at least most of you. The 5370 is traditionally reserved for new construction projects. They have recently, again, added a bunch of these quality-focused criteria into this document. You can kind of see at the bottom of the screen here, item P620 3.8 discusses retroreflectance, and we'll kind of zoom in here and just take a look at that in a little bit more detail. But the language speaks like this. It says reflectance shall be measured with a portable reflectometer meeting ASTM E1710, and it goes into a little more discussion about that. And so Greg and I really want to talk a little bit about more what all that language means, and we'll explain that. But they have a chart underneath that language that I've prettied up a little bit, but it essentially communicates this, that you have initial retroreflectivity or retroreflectance values for white, yellow, and red markings with type 1, type 3 glass beads in them. And you also have this initial thermoplastic retroreflectance criteria. These are not new. Those reflectivity ratings readings have been defined for about 5 years, 5.5 years. The new thing is this bottom row, which says all materials remark when below 100 millicandelas on white, regardless of B type. 100 millicandelas on white, 75 on yellow, 10 on red. They also, excuse me, they also add this item in here for this sub item saying prior to remarking, determine if removal of contaminants on markings will restore retroreflectance. And that's really smart. The FAA is very smart to put that in there. We'll discuss briefly about that. But the kind of the overall message here is that this is a maintenance criteria. They are establishing a minimum threshold for white, yellow, and red markings, and the only way to know that you meet that threshold is to measure. There's no other way to do it. And we'll talk a lot about how to do that and the solution for that in this webinar. Greg is going to tackle a lot of that.
Yeah, Mike, I would add this. It, the FHWA has been working for, I think we're at 14 years now on establishing minimums for retroreflectivity on our roadways. And I just want to applaud FAA. I'm sure we have some on this call today, on this webinar, but just that their action and so forth, because this is a big step. This is going to better ensure. A lot of times, we set it and forget it, unfortunately, and then without some type of guidelines for our folks to follow, I think it makes it really difficult. We find that on the federal highway side. Again, that's my background, folks, is in the highway area, and I think it's awesome that they've actually set these minimums now to give us some guidance as to when the heck we have to go out there and restripe these lines.
Yeah, thanks, Greg. I appreciate the ad there. We're hoping that the FHWA follows suit. So just let me preface this by saying that there is an incredible amount of technical information that Greg and I wrestled with whether we should include or not. We've trimmed this content down a lot in order to get you guys out of here on time, frankly. But just understand that there's a lot of technical information underneath a lot of the things that we're going to be talking about today that are on a little bit of a higher level for this webinar venue. So some visibility factors and some of the reasons that we use markings in general is that we need obviously some guidance, but in order to achieve that, these markings provide contrast, like white or yellow marking on dark pavement. Also, the light type and intensity, speaking to reflectivity or even daytime luminance, And color is very important as well. In the airfield world, in the airport world, we're really relying on yellow to communicate that we're on a taxiway, white to communicate that we're on a runway, and even red has been introduced in the last 10 years or so, really to indicate stop. So we talk about retroreflectivity as well. You guys will get a kind of a quick lesson in how that works in a very basic sense. And then we also talk about the characteristics of the marking, things like size, and that speaks to the width and the length of the marking, and those have information specifications for each marking. And then uniformity. We'll talk about uniformity as well, and how that really helps communicate an accurate message to the end users. And that's people in ground vehicles, certainly pilots as well. So we'll get into the actual reflectivity and how that works next, I believe. You are looking at a graphic here. Essentially, you have a binder, a pavement. On the bottom portion, you have a binder or a coating like paint, like water-based paint, and then a glass bead that's embedded in that coating. And that embedment is very important for retroreflectivity and how it works, and whether it works properly or not. So what you're seeing here with this blue arrow is basically the incidence of light, maybe originating from a headlight, for example. When light enters the glass bead, it refracts, it bends because it's a different medium. Once that glass bead refracts, it focuses on the back of the bead, and essentially it reflects whatever color it is embedded in. So you can see that arrow now turns yellow and is reflected back to the source of or the light source. And so when we see markings at night, we are actually seeing the diffuse reflection or that cone that you see around the arrow. That is, in essence, how retroreflectivity works. And there are lots of variables that influence retroreflectivity. The number one is paint. Whatever binder it's in, that has a direct correlation with the effectiveness of the retroreflection. Things like pigment, bond, and thickness of the coating all correlate directly with quality of reflectivity. We also talk about the glass bead. You guys are probably familiar with type 1 glass versus type 4 glass. You know that type 1 versus type 3 glass. You know that type 3 is more expensive, but they have different, they're constructed in a different way, but in different qualities. And certainly embedment has a huge, I think the aviation industry, in my experience, when we're doing airfield marking assessments, we see varying embedment significantly. That's a common theme during our assessments. We'll talk a little bit more about that. And then certainly the light source itself, the intensity, the angle of incidence, or how it reacts in the glass bead, and certainly the type of light as well.
Yeah, Mike, I think one thing I would cover a little more also is that uniformity side. We, of course, for the highway industry, and forgive me, I'm going to kind of go back and forth with that because there's a lot of things that that are connected between the two, and uniformity is important in two ways. One is uniformity from marking to marking type. For instance, that all of your hold bars look the same. All of your aiming points are generally the same. So they're identified, but also uniformity across the entire marking, which you'll be talking about, I guess, actually probably next, or in a couple slides from here. Also, yeah, paint, glass beads, light. I think, Mike, you hit it really good about the embedment of the bead. The embedment of bead affects everything from color to retro to durability. So that bead embedment is really important, something that's often overlooked by the stripers. All right, back to you.
Thanks, Greg. So we're going to be talking real quick about the top 3 marking defects that not only have, in my experience, have I seen doing these airfield marking assessments, but also a little more specifically with the tools that you'll hear more about. the top three that we see, obviously retroreflectivity, you guys could have guessed that. That's probably that's number one. It's the most chronic issue out there. We see, in my experience, that the quality of reflectivity varies significantly. Again, I've seen great markings. I've seen ugly markings. Number two is lateral deviation failure, and that's a fancy phrase for how uniform it is, how uniform it looks, particularly at night. And then we'll talk about color failure as well, both daytime and nighttime color. Number one, again, was that retroreflectivity. And I pulled this out of the FAA guidance or Part 139 language, specifically Part 311 subitem D. And FAA inspectors refer to this standard a lot. And I just really want to pick out this last item, the last two sentences here on this slide that says, each item provides an accurate reference to the user. And if you were in the room about 10 minutes ago, you heard me use almost verbatim that language. It's something that I rely on to, almost ask myself, is this marking, when I'm in the field looking at something, I'm saying, is this marking providing that accurate message? If it's not, or if it's even debatable, then we may have an issue, because a pilot or a user may see something else, see something different than what is intended. So some of the effects of poor reflectivity certainly is poor nighttime visibility. That's pretty obvious, but we needed to say it. Also, poor color recognition. Greg just doubled down on what I was saying about how embedment affects how color looks at night. If you are an airport operator and go out on the airfield at night, you probably have seen yellow markings that look white, or maybe a red surface painted sign that looks pink at night. And that's not proper nighttime color, and certainly affects color recognition. And then reduced durability. Greg hit that point too. Simply put, if a glass bead is not applied well, if it's not embedded properly, particularly if it's under embedded, meaning it's barely in the paint, it's going to come out, and that's going to affect its durability very, very quickly. Ideally, the picture that you see here on the right of these thresholds, I'll pat myself on the back here. This is a quality control job I did down at an airport, and this is the kind of result that we're really looking for. When the engineers draw it up and they design the project, this is what they're imagining. It takes quite a few steps, particularly with the application, the quality control, even the design, though, to get to this point. It looks like it's easy, but I'm telling you right now, it's a challenge. But this is what we're looking for. These markings convey an accurate message to the user. These are awesome. I love this shot just because it's in a low vis condition here. I'm not going to tell you where this is, but it's a top 2 airport. And you can essentially see, you can tell exactly where you are, even though you're pretty socked in with this fog layer. Some of the things that we also see are not as nice. They very often will. They'll look like this. It's like a horror story. I mean, this is some of the worst markings that we've seen. Here's a great example of what an intersection looks like daytime and then nighttime. You can probably see it on your screens, but that red surface painted sign, looks marginal during the day. It looks pretty bad, but it looks marginal during the day, but it is invisible at night. So these are the kinds of things that we want to avoid. A pilot goes past that whole bar and says, I didn't see the whole bar. It's like, yeah, we've heard that one before. But in this case, honestly, you cannot see it. So these are the kinds of things that we can avoid with proper application. We'll talk a little bit more about it here. So some of the causes, not having optimal bead embedment, what we're looking for is what is on the left. I'm telling you right now, I'd say out of all the marking samples that I've looked at over the last 10 years since we created the assessment service, I'd say 10% are in this category. basically in our excellent category for optimal bead embedment. That is what it looks like when the coating dries, and you can get a sense of how durable that marking is. Those beads are going to be there for a long time. Traffic won't take them out easily. Even snowplows and brooms won't be able to dislodge those beads. However, in this next picture, this white picture, what you're seeing there looks like the surface of the moon with all those craters. That's where beads were at one point. And based on just the depth and how shallow those beads are sitting in the paint, I'm going to guess that they were there for, a matter of days. It just doesn't last very long. So we're looking for optimal bead embedment. Here's another really just kind of a cool case study that Greg shared with me, and he thought it was important to put it in here. I just want to give you a sense of how embedment can really affect not only retroreflectivity, but color as well. Greg is going to touch on the color a little bit later, but going from left to right, you can see that optimal bead embedment or proper bead embedment yields about 250 millicandelas on yellow paint. If you over embed the bead in the next example to the right, you've got about 60. Going further to the right, you have few too many beads, causes something we call stacking in the industry. Basically leads to reduced visibility, believe it or not. And 90 millicandelas, it was the reading on that particular sample. And then you see here on the far right, you basically have beads that are under embedded, and while they may be bright enough to pass an initial standard, it likely won't last very long. You will have one of those poor markings that we saw previously. So embedment is probably the number one factor that leads to diminished retroreflectivity.
Mike, I'd like to add here, just these samples that you see, these are all the same exact material. It's actually, it's a preformed material, and it's cut off the same roll. So it is about as close to being identical materials to one another. And you can see even the visual appearance, the day visual appearance is slightly different, but the nighttime is significant, as you can see by the changes in the retroreflectivity between the units. Also, would like to mention this image back here. This shows the smaller beads in this image are near perfect, and they're at that 55-60%. It looks like. I would, however, point out that the larger beads, unfortunately, did not get down into the pigment. And we find that a lot of times a problem when we're doing a mixed bead application or a larger, a large and small bead application on the roadways. We find this when our pigment or our paint or our coating basically is not thick enough to let that bead drop into the material. So these larger beads will do kind of what Mike was talking about, was they'll peel out before long. They'll have an early release, and just the difference in a small bead and large bead. The smaller the bead, usually better dry reflectivity, and the larger the bead, better wet reflectivity because it lies above the film. Sorry, I'm a little technical on that side of it. So, but I just wanted to add that, and again note that these materials that you have here, they're all the same materials. The only difference is the bead embedment. And 251, this material could probably max out at about 280 with its design. So I'll hand it back over to you.
Thanks, Greg. Some of the other causes for retroreflectivity certainly are the coating itself. You really have these two fundamental parts of any marking system. It's the binder or the coating, and the reflective media or glass beads that you put in it. So the things that affect the coating, certainly the quality. I'm telling you right now, and you probably know this if you've worked with multiple paint manufacturers, not all paints are created equal. There are good ones and there are bad ones. That pretty much goes for anything, but paint is no different. Certainly the paint type and application. We'll talk a little bit about application here, but and again, the paint application, paint and glass bead application could be an entire webinar by itself. As a matter of fact, we we do an airfield marking symposium that does nothing but talk about the technical side of application. So I'm really just going to hit the high points here, and I think maybe that's in the next section when I'm discussing uniformity. But certainly, if you have spent any time on the airfield or particularly a runway, you'll know that some of the markings, mainly the runway center lines, lead-in lines, even high speeds, holding position markings, they very often can be affected by rubber deposits. We'll talk a little bit more about some of the other contaminants, but rubber certainly can affect your retro numbers pretty quickly.
Yeah, Mike, I also want to mention here that when we did the case study for Jacksonville, which we don't go over in that data, unfortunately, I didn't have enough room for it, but basically what we found was what's interesting is if those beads are properly embedded, in a situation like this that you see, you could still have your marking actually can be dark because the deposits, if you, let's say you go over it with a standard low pressure washer, 4,800 psi, something like that, and you knock that rubber off the glass of the beads, you actually get white retroreflectivity. The marking will look black still, but the reason is because remember in our diagram that light, that color is coming from the back of the bead, which is sealed between the bead and the marking. So it was kind of it was a very interesting thing. We started out with like 60 millicandela, we got it up to like 480. And just by cleaning off the top of that bead. Unfortunately, though, it didn't have the daytime contrast that it needed, but it was just an interesting point I wanted to make.
Yeah, thanks, Greg. That's a good point. Anecdotally, I've seen markings, particularly on asphalt, that you can't even see them daytime. They're totally obscured by rubber, and you go out at night, and it looks like they just were repainted because you can see all of the reflectivity. You're not relying on that coating. You're relying on all the glass beads. So it's yeah, rubber's certainly a bigger problem for some of the top airports, the large hub airports, but a problem in many others as well. This was an interesting anecdote that we took from our experience. Greg and I were involved with a conversation with an airport, particularly an FAA inspector was asking us some questions, and we took this little story, if you will, and threw it in here. This is all about lateral deviation or uniformity of appearance, and I'm not going to read this whole thing, but what I did want to mention was the last sentence, and he says, we need a way to determine the areas needing work in order for that practice to be effective. And that practice, he meant getting airports to understand that they can save time and money by doing just certain maintenance on their markings, but you got to be able to identify it. And he was saying, man, that would be really cool if there was a way to do that. Well, that's what this webinar is really all about. In the new specification, that P620 3.8 retro-reflectance, it says at the end of that, again, the last sentence in that says, the average reading shall be equal to or above the minimum levels of all readings which are within 30% of each other. That basically means that the standard deviation should not be greater than 30%. I mean, they should all be pretty close. Basically what this is trying to define, and it does, it says that, you know, if you take 6 readings, if you take however many readings you take to get your average, they shouldn't be, they should all be pretty close to one another. If you look at the pictures here on the right, this inspector actually sent us these pictures, and you can see that they may have measured their markings in these cases. You see the threshold markings below the designation there, and the threshold markings, they may have passed the minimum criteria for maintenance. The FAA defined it as 100 for white paint, but it would fail the lateral deviation or the uniformity standard of 30%. You can see it's kind of a small image, but you can see that it is not uniform. And so that's really what the FAA is trying to establish, is say, hey, you need it to be bright, but you need it to be uniformly bright. That's what we're really looking for. Again, in order to communicate the proper message to the end user. I'm not going to tell you where this is, but it's a top 10 airport, and this is when I first consulted with them. They're doing things much differently now, but when I first consulted with them, this is the kind of thing that I was looking at. This is another airport entirely, but if you guys have ever seen either a contractor or perhaps you've done this on your own, this is a hand applied marking where they were spraying paint and then hand throwing glass beads on top. That is actually it's prohibited by the FAA. It's not an approved practice, and it's also a poor one. This surface painted sign, again, it's supposed to look uniform, and it's really supposed to look yellow too. We'll talk about that in a minute. But this is where hand throwing glass, hand application of glass just doesn't provide the proper message to the end user, and some of the tools that we'll talk about later can identify those things as part of an assessment. The direction sign here for Taxiway Alpha, that's awesome. I mean, that's what we want on our airfield. So that is communicating the proper message to the end user. That would pass the FAA's new uniformity spec. So some common causes for this, for basically non-uniform markings, the application is number one. Things like bead distribution or disbursement, embedment. We talked about that a little bit, and how that can affect it. The selection of spray tips. I've trained a lot of airports over the last 15 years and have realized that they don't all use the same equipment, even right down to the type of tip. So all I really want to say about this is that there's a right way to do things, and then there's every other way. But you want to spray your paint or whatever coating uniformly. The uniformity of that coating is as important as the even distribution of glass beads. It is absolutely as important. I mean, as you were probably seeing in some of those pictures, when you have a non-uniform application of paint, then your beads, some of your beads are sitting high and they are under embedded. They might look brighter than the beads that are properly embedded. Not to mention, a couple of months down the road, the beads that are sitting high are going to come out, and then so that isn't going to be totally non-reflective, and the beads that are still there. So you understand that certainly coating uniformity is a big part of this. And then again, rubber and other contaminants, they can absolutely affect how marking looks. Here's a great example of a runway centerline that has some rubber right down the middle of it and on different portions of it. And Greg has actually overlaid this color, this kind of green to red scale of how bright the marking was reading, and I believe his mobile unit did this, the G7. You'll see that in a minute. It basically identified that, hey, reflectivity was poor right in the middle and on the right side of the marking, but the rest of it was good. That's the kind of technology that we have available in order to identify markings that are perhaps non-uniform and maybe wouldn't pass the FAA's new spec. Okay, and we also have color failures. Guys, I'm running a little bit behind, so I'm going to speed up a little bit, but you can see on the right, we've got some pictures here. That's actually rust contamination, but certainly dirt and debris, fungus, like algae. We see blue-green algae growing. I was just in Vancouver, and it's there. And as you can imagine, it's also all the way down in Miami too. So it really, every corner of the states has at least the potential. Perhaps it's where we choose to build airports, maybe that. But the other big one that I think everyone that is probably on this call is familiar with is the UV stability. When your reds turn pink and your yellows turn that creamy color. A lot of things can contribute to that, and we'll show you a few more instances here of color failures on the airfield. Nighttime, particularly when we apply these markings, this is a great looking marking actually on the right side with respect to the pattern and how well it was applied. I will say that I'm going to guess, just based on the the way that yellow looks, it looks almost white. And so, once again, I'd bet that the glass beads were sitting a little high in the paint. You can see in the very bottom left of this slide, that is the front side of a LLG7 mobile reflectometer. You'll hear more about that in just a couple minutes, but it has the ability, and as a matter of fact, it's the only machine that has the ability to measure nighttime color and determine whether it's passing or failing based on ASTM. You can see it up there at the top of that, the white chart, ASTM D6628. And in that chart, I just want to point out, this gets a little technical, but you can see a little white box kind of above that that outline of a little parallelogram, little white box and a yellow box. Those are basically the color tolerance for nighttime color. And you can see where there's a red dot right on the right-hand side of the white box. And that is a yellow marking that is appearing white through the lens of the glass bead. So that's what that G7, that mobile reflectometer, is able to do. And that really helps us. And again, it's an objective measurement. It's not, your ops agents telling you one of them says it looks fine to me and the other one says it looks white at night. This is an objective measurement, which really does help us define maintenance.
Mike, this is actually a problem that we see again back onto the highways. We just did something called Measure Across America, where we measured 1,100 miles. We're about to do about 6,000 miles of line striping assessment. Just to get an idea of where we are, kind of the state of our roadways type program. And what we found in the brief one, in the pilot project, that about 26% of the yellow lines were not reflecting yellow. And when I brought this to the attention of one of the largest states and most aggressive with pavement markings, I thought I'd get in a little trouble because their failure was pretty high. But they actually thanked me. They said, we just haven't had the ability in the past to do a network level, is what we call that when we use a mobile on a roadway system, network level measurement of color, and how important that is. Of course, on a highway, it can be dangerous because you cross over that yellow line thinking it's a white line, and you could end up in a head-on collision. But of course, in Airfield, you do have the situation that what is a taxiway may look like a runway marking, and if nothing else, just causes distraction and confusion. So yes, and that's exactly what happens. A lot of times that yellow will bleed over into the white before it'll go anywhere else. And Mike, you pointed out that high beads is a great. Not great. It is the most common reason that you'll have that. Besides not a good bond between the bead and the pigment. Let's say it's a cheaper pigment or a not so good paint will cause that problem as well, that it won't be able to reflect its color. And that really started when we went into, years ago, we had to go from leaded yellows into organic yellows, and we lost a lot of that ability to reflect that yellow. So there are many different types of pigments and many different types of paints and so forth. So your paint quality has a lot to do with it as well. And Mike, are you still there?
Yeah, I'm here, Greg. We may have some audio problems.
That's okay. That's all right. So we're going on to what the common causes are with regards to color failure, and we kind of talked a little bit about that. I'll take over here on this one. I'll just tell you, it's beads and coatings. It's back to the same thing. If you notice, I pulled up the same chart, and you can see that beads too deep versus actually the one on the second from the left. That yellow passed the one next to it where there were too many beads, which is I think Mike pointed out, is a really big issue. A lot of people think that if one handful's good, two handfuls better, and that is absolutely not the case. So that yellow failed because there was just too much glass on top of glass shadowing one another. And then, of course, the beads too high that we talked about on several occasions as well. Too deep, too shallow, too few, too many, all those things can cause that color to fail. And then, of course, with the paint, as we have with the daytime issue, is its UV stability. Its initial color is also a potential problem as well. Anything you want to add to that, Mike?
You said it well, Greg.
Okay, well then I'll jump us into assessment methods. So this is, there are three primary assessment methods when you're assessing an airfield pavement marking. One is visual. That's me on my hands and knees, actually taking a photograph. It's amazing what you can get with the type of, a lot of our pictures that we take of bead embedment are from our smartphone, so pretty cool. There's also handheld, and that's a great device to use. We'll talk more about these in just a moment. And then, of course, mobile. So we have visual, handheld, and mobile assessments. All are important. Let's go over each one real quickly. So the advantages of a visual inspection is that you're able to get real close, as I said about taking the pictures, get real close and look at the bead embedment and the disbursement across the line. You can also look closely at the paint. You can check the condition out. You can check the adhesion. Again, this is oftentimes a type or quality. It could be a really good quality paint. It's just not the right type of paint for the application. We found that in our assessment out in Jacksonville, and was able to help them to pick the right type. It didn't really matter about the brand as much as making sure they had it had the right binders in it, and resins. Next is disadvantages, is that there's no numerical assessment that's taking place here. So it's extremely subjective in your inspection. And it's slow when you're trying to get a close view. It can be fast if you're driving down the runway in a car with the headlights on. That's pretty quick, but normally if you want a real good look and you're looking at embedment, disbursement, and condition and so forth, it's a pretty slow process. Also, it does require nighttime inspection. What a line looks like in the daylight does not tell you what it looks like at night. It's amazing what you'll see. In our measure across America, we found lines that were brand new that looked beautiful. I mean, it just beautiful. But when you come back at night, you can't even see them. Also, personal safety. You are crouched down in the middle of the runway in this particular case. Then we go over, what do we use? When is it the right time to use visual inspection? Routine visual assessment and post-measurement inspection. So routine visual assessment, you're kind of doing drive-bys, you're walking through it, your guys are out there replacing lights and they're looking at the markings at the same time. They can look for adhesion, color issues, make sure the contrast is there. And really at night, you can check for brightness, not necessarily retroreflectivity measurement, but you can check to see how bright that material is. Post-measurement inspection. So anytime we do even if you do a full assessment with a mobile device, there's going to be some visual inspection that you'll want to do. And if you see a problem, you can go out there and you can check for bead embedment and disbursement. You can check for adhesion again, and then your daytime width and contrast in color. So these are all the things that you would do after a full measurement inspection to basically follow up on that to make sure that everything was in order, or even be able to identify issues. Then we go to the handheld. The handheld unit, its advantages is you at the same time that you're operating the handheld, you have the opportunity for a visual assessment. You can get back down and take a look at it, and you see a low measurement, you can look at it right then. It is a numerical assessment, so it's not subjective. It actually gives you an exact reading of millicandelas per meter squared per lux. And longitudinal and lateral markings, you can measure either one of those. We'll talk about how that changes when you get into a mobile. So you can do pretty much all markings with a handheld. And you can do daytime or nighttime assessment. I believe with every machine out there that's a handheld machine, you can measure both during the daylight or nighttime. That ambient light does not affect the instruments. And you get pass-fail capability. So you're able to set the limits and say, okay, If it's 100 or more, then it's pass. If it's 100 or less, it fails. Mapping capability. This particular unit, the StrikeMaster 2 Touch, has a GPS in it, and so it's every time you pull that trigger, it logs where it's at on the runway. Disadvantages: it's slow. It's as fast as you can walk and pull the trigger. So it's a little bit slower, especially when you compare to the upcoming mobile. Also, it's not comprehensive in such a way as that you're probably taking measurements every 20 feet, 50 feet, 100 feet, whatever you decide that number is going to be, that interval. And the slower or the tighter that interval, of course, the slower the assessment's going to be. It's not as comprehensive as a mobile device would be. And personal safety, you're out there on the runway or on the taxiway. In fact, when we're doing this, I was out there during this time, and there were many times that we had to vacate the taxiway to make way for an aircraft. So it's a little spooky. You guys are used to it. I'm used to highways, but I'm not. There's a difference between a vehicle and a 737. So it was a little spooky for me. Then we get what are the purposes or uses? The right tool. What is the handheld right for? The uses is periodic maintenance. To go out when you're out there, you're restriping an area. You can go out there with your handheld and check and make sure your team was able to install that marking right and get that bead embedment we're talking about. Also for contractor quality assurance, this is really important. A lot of times contractors self-certify in some situations. But it gives you a chance to go back out there and say, okay, I knew it didn't look right. Here's the readings, and now it's not just you saying you're not happy with it, and you actually have a number to show them. Also, this is an excellent tool for lateral markings of less than 200 feet. We'll explain that in a moment, but you can do longitudinal markings as well. Again, it just becomes slower, but it is an excellent tool for your smaller markings. In this graph here, you see a runway, about 9% of that runway can and should be, the handheld is the right tool for it. And then on a taxiway, 19%. Again, this is really for full assessment. The instrument can be used on any markings anywhere on the airfield. But if I was doing a full assessment, I would expect to use a handheld and a mobile, and probably in those proportions approximately. Then we go to mobile assessment. So the advantages of a mobile, it's fast. You just really can outpace the equipment. In fact, I think we can top out about 180 miles an hour. I've actually measured at 110, so it was kind of fun, and it was on a rehabbed airfield. It wasn't on an active airfield, but it was pretty interesting. But we were able to, you're able to measure at any speed from 5 miles an hour to 60 miles an hour highway speeds. Personal safety. You're in a vehicle. You've got lights on it. It's got the radios. It's you're safe. It's one of the safest ways to be out on the airfield. And then comprehensive assessment. You get an incredibly comprehensive assessment, which we'll show you some more of that later. Multi-level ratings. Instead of just a pass-fail, you can say, well, this is good. This fails. This needs to go into maintenance within the next 6 to 12 months. And this one's going to last. We don't really need to worry about that for about a year. And then this one, who knows when I'll have to be back out on it. Mapping capability, like the handheld. You actually get you drop it right into Google Maps, and as you see there in the center image, and be able to see what your airfield looks like. Data control, as you can see in the top right image, there's a lot of data that you can work with. A lot of it is taken automatically, but some of it, as we'll talk about in a moment, you're able to manually enter as you're doing the assessment. Disadvantages. Lateral markings. Lateral markings under 200 feet are really kind of a pain. We did do some, but you can't take that. You don't want to drive into the grass at all, but you certainly don't want to drive into the grass with a $100,000 instrument sitting on the side of your car vehicle. Minimum visual inspection. So you're driving along at anywhere from 0 to 60 or 5 to 60 miles an hour. And so you really don't have a chance to look down and see what the cause or what the problem is. We do find that when we see those measurements, something drop, we may stop the vehicle, get out and do a physical examination or a visual examination just to really learn from it as much as anything else. Where we would use a mobile is annual and semi-annual network assessment. We use the word network in the roadway industry. For instance, the state of Florida, I think it's around 50-something thousand miles a year that they assess. They do a full assessment of all state-owned roadways or state-managed roadways every year, and that's called a network assessment. In your case, the entire airfield would be assessed. Maintenance planning. This is probably one of the greatest uses for these, is because if you do an annual assessment, then you can start planning your maintenance by what is happening. You notice, as you'll see here, hot areas that tend to wear faster than other areas. So you know at some point you get to that area, that plan where you're able to go out and mark something because you know that within 3 months that's going to go bad. Then we have, of course, the different types of markings, longitudinal markings and lateral markings of 200 feet or more. Again, kind of looking at the same chart, just reverse. 91% of the runway markings can be measured by a mobile, and about 81% of the taxiway markings can be measured with a mobile retroreflectometer. So if you're doing a full assessment or a periodic or QC assessment, these are the tools that we recommend. If you're doing a full assessment, you should do it with a mobile retroreflectometer, much less downtime than if you're trying to do a handheld. And you do need a handheld for those smaller lateral lines, and then of course a visual inspection to back it up in case there's something not coming out right. You want to go out and take a look at it. When you're doing periodic or QC assessment, then definitely a handheld retroreflectometer and a visual inspection will do just fine. Do you have anything to add there, Mike? I'm going to go on to the Jacksonville case study next.
No, you're rolling. Go for it.
All right, real good. Okay, so this is the Jacksonville case study. This is Jacksonville International Airport. And the case study really initially was started in 2017 and was to determine and develop the best practices of use of retroreflectivity assessment instruments in the airfield. Up to this point, there really hadn't been much use of a mobile device on an airfield. You know, our senses told us, what we thought as being in the industry, in the retroreflectivity industry, we were thinking, well, it's not like you're doing 1,000 miles of marking, so a handheld should work. Well, with the safety factors, the speed factors, the factors of needing to get in and your short windows and so forth, all those things actually made a mobile device a very ideal instrument to use in the airfield. We did partner with JAA on this. We appreciate them letting us share their data that we received, and this is just a brief kind of overview. We got a lot more detail, believe it or not, than this. So the retro-reflectance is what FAA is calling it. We call it retro-reflectivity, all the same. But the retro-reflectance breakout. So this was interesting. Jacksonville has some very high standards. First of all, they're using Type 3 beads on everything. And so they demand excellent retroreflectivity, and really, quite honestly, they got it. So very impressive. I think their average was 631 millicandela over their entire airfield, so that was pretty impressive. But you can see here what they said was anything that's under 300, we want to look at remarking. Anything that's between 3 and 499, we want to put it in some type of maintenance schedule. And then the others are just kind of, oh wow, this is great. And then you see the 900s, and there's 25% was 900. Now we go to 2018, and we did the same measurement about 12 months later, 11, 12 months later, and you see the change. Now, We went from maintenance and replacement, that's the red and yellow, at 30, 45%, and then it went up to 57% in 2018. Now you may say, well, gosh, when they start looking at it, now it's going down. But part of this, quite honestly, was where we learned a few things from our assessment in 2017, and we were able to take it and what we feel more accurately measure the markings in 2018. So I would say that there probably wasn't as much of a change as we see. It's just we were able to nail it down a little bit better. Now, what's interesting here is that FAA came through and they said, okay, anything under 100 on white, anything under 75 on yellow would need to be replaced. So what I did was I took the information that we had in JAX, and you can see again that's 57% in 2018 fell in the replacement or maintenance category. Now, what I did was I said, okay, if it's under 100, it's replacement. If it's under 200, from 100 to 200, let's put that in a maintenance bucket. And really the reason is because once you're at 200, if you started out at 4 or something of that sort, you're gonna, you need to start watching that marking. So you can see the difference between Jacksonville's expectations and the FAA, we'll call it expectations. Again, understand that the only minimum and the only requirement that has been set forth by FAA is the 100. It has nothing to do with the 200. That was something that I selected just to give us a 100 increment there. So you go from 57% needing to be replaced or put in a maintenance program down to 14%. So you can see the requirement, the change in the requirement also made a change in the need of replacement. I do want to mention here, and we talk about it a little bit in the cost savings area, but if you were restriping this, I would bet that you would be on your maintenance program, you're going to restripe more than 14%. So assessments are really helpful in reducing that cost of striping when you don't need to stripe. Next is I wanted to show, this is the same information except with, I split out the runways and the taxiways. We found that there was less taxiway failure and maintenance lines, markings, than there was on the runway. And I guess everybody here can guess why the runway was higher. And that is, of course, because of the rubber issue that you have on the runway. In 2018, this is our map. We were talking about being able to map things out. This is green. This means that marking was at, I believe, 900 or higher. Then we get a little bit lower. We get a little bit lower, and these are the markings that need to go into maintenance, and these are the ones that just need to be replaced. So you can actually use the LOG7 will adapt to Google, and you can go in and actually click on each one of those bubbles, and it'll tell you exactly what that measurement was and exactly where it is, and you can zoom in and so forth. They all look like they're in the same spot when you look at it from this distance, but they're very, very different. So that's our mapping capability. What we wanted to do was talk about when we went 2017, we did a retroreflectivity assessment. And that's pretty much all we did. We just went in and we looked at the retro. In 2018, after spending time in the airfield environment and so forth, and being able to relate it to the highway environment, we were able to identify that, first of all, as you saw in those things that the visibility factors that was shared with you early on, there's a lot more to visibility of a marking than just its retroreflectivity. It is its color, its uniformity, its contrast, and so forth. So when we went back, we said, okay, let's look at two things. First of all, I want to better identify and segment the markings that we took. It's nice to have it all on a map, which it does very well, but we wanted to be able to split out those things. We'll talk about that in a second. And then, of course, marking quality rating score. So we kind of we added some things to not just retro, but added more items to it. So let's look at marking identification segmentation. We were able to actually, on 2018, we had a general area, runway, taxiway, apron, area specific, runway 826 or taxiway G or apron northwest. We had color, marking color, white and yellow, and marking type, aiming point, taxiway, center line, and non-movement as examples. So we're able to, by doing this, we can segregate those or segment that data and say, for instance, if you wanted to know, how much white you were going to have to replace, you could run that. You could say, well, where did runway 826, how did it do? And what about just its aiming points? So it's really nice to be able to go through that data, and you can make great management decisions with that. Note that beyond the data, just the segmentation advantages, this also helps the machine to know. It kind of gets a little AI going, popular phrase these days, artificial intelligence. And what we see is that we're able to, that machine now knows that should be a yellow line and it should be 12 inches wide. So it's a very good method. It's kind of a cool thing that we've just developed this, and for the 2018 project. Ratings, rating and scoring. This was addressed through Mike with about regarding the lateral, what we call lateral deviation. Just basically, there's a longitudinal deviation, there's a lateral deviation. Longitudinal is hey, it changes from bright, from 300 millicandela to 100 millicandela as you're driving along. And then, of course, lateral is the width, the change or the deviation of the retroreflectivity from left to right. So what we did was we said, okay, let's get retroreflectivity, and we're going to put it in our 4 buckets. Remember, we had those 4 buckets earlier. And those buckets are all, understand that those are all customizable. So you can, if your airport wants to hold a higher standard than FAA, you're more than welcome to. In fact, in the highway industry, FHWA's numbers that they're going to submit here soon are far lower than most states. And a lot of states, probably about 25% of the states now, have their own minimums. And so they're going to maintain their minimum, a much higher minimum than that even of the FHWA. So you can decide what those are. Also longitudinal deviation, so it's kind of looking for that. Is there a change? Is there any dramatic changes between 1 foot to the next foot to the next foot? Actually, we're averaging about every 5 feet. Lateral deviation, we talked about that several times. And then we have a compilation score. So we have a score that takes all these into account and then gives you an overall score. And then, of course, a color pass fail, which the LLG7 color is the only unit that can measure, that a mobile unit that can actually measure white and yellow or any color for nighttime color visibility. So just to show you some of the things that we were able to acquire here, we did a total assessment. Nearly 48% or so was runway, 48% was taxiway, and the rest was aprons. This is kind of a cool chart. Remember, I told you we could break this out. So you've got aiming point, apron, and it goes all the way across. You can all these different markings. And what you see is you see 4 colors there. And I'll just explain very briefly. The far left color is the retroreflectivity. And then the next color is red, and that red is lateral deviation. Now, I want you to kind of look over, go toward the middle, and it says runway center line. Now, you see how high the retroreflectivity is. It's scoring out about a 1.75. But look at the lateral deviation. So this is an easy call out because I know what that is. That's rubber interfering with causing a deviation problem in the measurement of that line. So because it's scored so low, even though it's scored fairly decent on the retroreflectivity, it actually scored, it's saying, okay, we need to take a look at this because if the deviation is low and the retro is high, we've got an issue here. And then some are right on, pretty much on the money, like the aiming points and so forth. But at the far right one, just so you know, the green one is for longitudinal, and the purple one there is for the comp score. Next is this is just a breakout of the retro. This is a breakout of the lateral deviation. You can see nearly 50% actually failed in lateral deviation. There's, as we said, there's a lot of problems that we could go over and what causes that and how we can fix that. Longitudinal deviation. This actually breaks out, if you look, it breaks out all the runways. This is exact areas that's taxiway C, and it gives you the same ratings and so forth. And then the compiled score. Something before, I've got another computer here that's trying to tell me to close, and I want to bring this up before it does. So in this assessment, we did sorry, let me grab my glasses here. We did in 4.5 hours, we measured 2.6 million valid scans, 38,000 averages, and I can't get to the linear feet now, it figures. But the point here is that we did all these measurements. We did that type of measurement in a matter of 4.5 hours. We were able to get in there and get out of there, and the airfield could function, and we didn't interrupt the airfield operations, which was really nice, and probably one of the biggest things about using that type of machine, a mobile device. So I've talked enough for a moment. I'm going to hand it over to some keeping it simple best practices with Mike. Mike, it's yours. Well, we're going to give him a second longer. I'm sure I might be able to handle it if... There he is.
Thanks, Greg. All right, so a couple best practices just in regards to not only an assessment being performed by a third party, but assessing yourself. Certainly the inspection process, the number one thing you got to know is the spec. And then really that goes for new construction, or it goes for basically a inspection of your own airfield. You got to make sure that you're meeting the specs as they're written. You can do that, again, just to cover what Greg discussed. You can do that through a visual inspection, which I think most airports do with their operations personnel, at least on a daily basis, if not, during every shift. Certainly periodic handheld inspection, just in my experience, just like Greg said, I use that on small markings, or when I'm doing quality control, for example, watching a contractor, making sure that if I'm providing quality assurance, I'll use that handheld unit to verify that all the reflectivity is what it is. And then the mobile, the more comprehensive inspection, that's what we use when we're doing airfield wide reflectivity analysis. And then certainly, all of those things, the results of those inspections really are so much of it. The results really do come down to how it was initially applied, and really even what bucket. Greg was talking about maintenance bucket versus deferred maintenance. It really all comes down to how it was applied initially. Again, you got to know the specs, and you have to use quality materials, both paint and beads. And training personnel, it's something that I'm hoping the FAA comes out with in the 5340-1M. Perhaps we'll have a webinar on that when it does, but we've been waiting for a little while for that one to come out. So I keep hearing that it's days away, so we will see.
Yeah, Mike, I'd like to just comment on that maintain training of personnel. I think it's all kind of obvious to some point, but here's something that I find a little different in the airfield environment versus the roadway environment. The roadway environment, these guys are stripers. That's all they do. Every day they eat, breathe striping. Some are even extremely passionate about it, funny enough. But when we get into the airfield area, if they're doing their own markings, what I've found, Mike, is that a lot of these guys are the same guys that change the lights out. Sometimes the guys that mow the grass. So I see this they're kind of the jack of all trades out there. And in my experience that I've had out in the airfield, I've seen a lot of no-nos. I've seen a lot of things being done that really should not be done, and it's going to cause problems down the road. It could cause some initial problems, but it definitely can cause some problems down the road as well. So training, I think, is just absolutely critical, because no matter how much we inspect it, if it's bad, it's bad. So just getting it down right, as you said, it all stems from usually the application. And a lot of times the material, but frankly, it's usually more of an application issue, says the manufacturer of products, right? Okay, great. I I did want to go over this real quick. This is kind of cool. Just some quick math. There was 485,000 square feet of markings at the Jacksonville airfield that we were looking at. And what I did here was I said, okay, if you were to, some airports, not all, but some airports will just, they put their markings just on a rotation, and the states used to do this for their highways. So they just said, okay, but it was kind of like it didn't matter how much traffic there was or if it needed it. It was just in that rotation. So we find that a lot of airfields do the same thing. They'll have a rotation. And so therefore they'll go out in a matter of 2 years and maybe repaint their entire airfield. But what we find is that that's not absolutely necessary. In this case, even with the high standards that Jax had, Jax had minimum of 300 for restriping, and 499 it would be maintained within the next year. That was about 45% back in 17. That was about 45% of their markings. So to restripe the entire marking set, let's say in 2 years.
Multiple people said lost audio.
Okay, seems like I may have lost audio.
I can hear you, Greg, for what it's worth.
Okay.
So it shows audio there.
Okay. Sorry, we want to make sure we don't have a technical glitch. We have some people that says that we've lost audio, but you can hear me, Mike, so that's good. Mike can hear me. Check with the backup in there. Okay. All right, we're going to try this again. Okay, if we lost audio, maybe. Okay, we're back. Okay, very good. All right, so what I was saying was, we had 485,000 square foot of markings on this airfield, and if they were to rotate that in a 2-year period, say basically restripe because it was in a cycle, restripe that entire airfield within 2 years, it'd be about $218,000. Now this is taking a lot into account. Some I think is low, some people will think is high. Besides, remember they are using Type 3 beads. This is where, I mean, good gosh, when you're using a Type 3 bead, you need to really be watching your marking program. The quality of paint you're using, how often you're striping. You really need to be doing those assessments, because that is a very good investment. It's expensive investment. It's a good investment. But you would have about $218,000 go out and restripe that in 2 years if you had the high standards that you have with Jax at 45%. Now take that down to 14%, which is what the FAA comparison was, if you remember going through that math. It's about 100,000. So there's a 55% savings by going out, minus the cost of whatever that assessment is, or that either a mobile or handheld assessment. But you're saving about $120,000, which is about 55% savings. I thought this was really important to bring up, because the states have found this out. So what they do now, instead of putting them in the cycle, they do these annual measurements, and they're saving a ton of money because they're not going out there and striping roads that don't need striped. But most importantly, they are striping the roads that need to be striped. So they're able to do that without throwing money at it. So I just want to kind of share that cost savings that you can have through a proper assessment. So when you look at this new requirement and so forth, and you think, another cost, well, it actually, in the end, it will end up saving you money.
Hey, one thing I wanted to add to that, Greg, in the airfield world, is you kind of use this punctuation on the end of your statement. I agree with everything you said. In the airfield world, we don't repave every 3 years for some roads. So what we find is constant, usually annual painting right before Part 139 inspections. We get buildup, and I'd say 50% of the airports that I've consulted with in the last 10 years, they have to implement a removal program before they can even enjoy this kind of thing. That said, I mean, they had to do an assessment to find out what they had to do, but we deal with FOD a lot of the time, something we don't see on the highways, but the paint buildup is a serious FOD issue, and very often you almost have to get down to a good substrate and a good application before you can start deferring a lot of the maintenance. But it's it's important to get out there and identify those areas and put them in the proper buckets.
Yeah. Thank you, Mike. And just talking about that, we're actually trying to work on a project now. That's what we do. That's why it's Transportation Safety Innovations, is possibly creating a coating that will better resist this. The problem that you have with a lot of things is you want it to do this, but you don't want it to do that. In our particular case, our struggle is that we need the friction for skid resistance, but yet at the same time we need it to be resistant to dirt pickup, or in this case rubber pickup and so forth. So very good. Thanks for bringing that up. So when we come to the end, as far as we're going to have some questions and answers. What can we do for you? Well, consulting or service. We can do an assessment service through AMA. That is Sightline's group, and he can tell you a little bit more about that. And I highly recommend the training. I'm all about training. By the way, we do have some Pavement Marking 101 and Retro-Reflectivity 101 courses on our site that you might enjoy. They're free, and it's similar to what we do here, just kind of a little bit of an open mic, but we go through all the different types of markings and so forth. And then on the supply side, we can offer either a mobile retroreflectometer for purchase or handheld retroreflectometers we have purchased, and we have just started a rental program. We were doing that for contractors for the handheld, the StrikeMaster 2 Touch, that we can work with as well. Mike, do you want to touch any on your consult services and assessment services?
There's more information on our website. It's already 3:15. I would just say that the actual service is something that you would contract out versus procuring your own equipment to perform your own assessment. There's advantages and disadvantages to, I think, both. That said, Greg is the guy to talk to if you're interested in procuring something as far as a piece of equipment to do it yourself. I'm the person to consult or to contact if you're interested in contracting out, having us come in and do the service for you.
Okay, great. I'll open the floor up for some questions that you may have, and we'll if you can throw those out in the chat box if you haven't seen that yet, and hopefully we can get some questions answered. By the way, we're very impressed. This is, I think we ended up with about 150 folks, professionals on this call. So it's been our honor to be able to share this information with you. Are we both going to be in Tulsa in April? We will be. I'm at this moment, I'm not going to be there. We will have a representative there, which is our retroreflectivity professional. He's the one that handles all of our retroreflectivity equipment. That's Chris Adkins. I believe he's even on this call. So he will be there representing us. And of course, Mike, of course, will be there because that is what is symposiums, right, Mike? Is that when your symposium is?
Yes, sir. April 17th to the 19th. If you just want to go to sightline.us, as in United States, sightline.us, click on symposium. You'll see the three we're doing there. We're going to be in Tulsa, April, San Jose, which is not a bad destination, in July 23rd through the 25th. And Tampa is no slouch either. I've already seen some people that are from the Florida area pretty close to Tampa. That's September 17th through the 19th. Greg, you got to join us for that one. That's a drive for you.
Yeah. We were just down there for American Traffic Safety Service Association for our annual expo, and it was excellent. It's a great place to visit, great place to be. We did have another question. A website for rental. If you'll just go online to pppcatalog.com and look up the LLG or the StrikeMaster 2 Touch. I do want to remind you, we will be sending out a survey after this. Should be right after this. You'll get one, and it'll go through and really just, if you'll fill it out, first of all, help us to be better at what we're doing. Also, it's an opportunity for you to reach out to us and say, hey, we'd like to know more about assessments, or we'd like to know more about the equipment or the rental program, that type of thing. So please fill out that survey. That'll help us to, like I said, the big thing is help us to be better at what we do. You have
Hey, Greg, I just want to address Rachel's question. She asked if painting over cracked ceiling affects reflectivity. I don't have any data on it, but I know it can affect color of the coating, and I'm going to guess that is that discoloration is uniformly affecting the entire coating. So I'm going to guess that it affects the reflectivity overall, but probably on a relatively minor scale. If you have any experience, certainly elaborate a little bit more for us.
Yeah, Mike, I would agree with you. Basically, to understand, so our retroreflectivity is coming from the top of the material, not necessarily the bottom. So because as long as you have that continuous bead embedment, that it's somehow not interfering with that, you shouldn't really have a decreased retroreflectivity. And also, unless the other side is that if you're, think about this, if it's a white paint over a black crack fill, your paint is not thick enough. You don't put a heavy enough coat down, which is a problem that I see in the airfield a lot. So in that situation, your bead goes to embed, and instead of embedding into the white, it can actually get down, touching the black, and then you're going to have some problems. So as long as your paint or your coating, whatever coating you're using, is thick enough, and you've got good embedment of your beads and a good coating material, you should be fine with that. And so that's probably what I would be most concerned about. And next question. Greg's reading them out to me.
Yeah. So, how often does FAA require selectivity measurements? Retroreflectivity.
Okay, Mike. There's one on the FAA requirements of retroreflectivity.
Yes, that's Guy from Boise. Hey, Guy. I would. They don't necessarily require a frequency of measurements. They also don't require. I don't know if you took a look at that spec when they talk about 6 readings in a 6 square foot area per the ASTM 1710. They don't tell you how frequently you're supposed to do that. So if you're on an aiming point marking that is 4,500 square feet, just like on your runways in Boise, 6 square feet is a drop in the bucket, so to speak. So that's not really defined. What I would say is annual for mobile assessments, so that comprehensive assessment. But if you own your own, you could probably do it a little bit more often. If you're contracting them out, if you're a really busy airport, maybe semi-annually, but I think, especially if you wanted to start to look at how your markings are wearing or really get a sense of wear trends, so you can start to predict, okay, well, taxiway Bravo centerline lasts 2 years, but the edge lines last 6 years. It's that kind of thing you might want to do a little more frequently. This is a long-winded answer to say I would do it annually if you had a mobile or if you contracted the mobile out. And if you had a small machine, you could do it daily. You could do it, almost on a rotation where you tackle one runway or one taxiway a month, for example.
Yeah, I think that's a really good point. That periodic, going out there and really that's where that visual inspection can come into play as well. But if you really, what's important is that you meet those numbers. So obviously, it's going to be more productive if you're out there measuring with an instrument. I wanted to bring up we had a question about flow rates of your paint machines and so forth. And in that, since the questions are being asked, I might as well kind of address that a little bit here. One of the things, so the question was more specific to how do we check for the flow rates, and does a third party do that? And I know, Mike, in your symposium, you actually go over flow rates of beads and paint. And some machines actually have that. They'll tell you what millage you're putting down, and it basically calculates the gallons you're going through and the feet you're measuring. And that's really the best way. But the best way to ensure it really is more toward using the right tip, using a tip that's not blown. You will go through way too much paint if the tip is blown. There's 2 types of tips out there, guys, that are used. One is an architectural tip, and one is a line striping tip. So when you're doing lines, a 12-inch line or less, something that a single gun can handle. Definitely line striping tip is the way to do it. It's basically it's the same thickness from edge to edge. Now an architectural tip is a feathered tip, so it actually has a feathered pattern. And this is sometimes what causes this lateral deviation, is that they'll use a striping tip for a large format marking. And so you have this massive, this significant overlapping. And so you're either putting in too much paint or too thin, too thick. It's kind of going back and forth. When you're using when you're doing a larger format, we recommend going with an architectural tip. Let those overlap nearly 50% or so, and then you're going to get a much more even flow of paint and volume of paint. There are wet mics out there, wet type. Jesus, it's failing me. Mill gauge, thank you. There's mill gauges out there. That's what you're really wanting to check. What I've found is that we tend to put too little paint down most of the time. However, there is a caution to put too much paint down, especially if you're not using the right type of paint, because some waterbornes are not designed to be built very high at all. In fact, they'll crack up and remove themselves. Now you got FOD on your runway, so you have to be careful there. So that's a long-winded answer to your question, but basically the best way to check your flow rate is to get out there and stripe, because remember, when an airless machine specifically, it's about the tip size and the speed you walk. If you have a tip a certain size, you can either put down a lot of paint or a little paint. It just depends on how fast you walk. So you gotta check your striper, what he's doing, what his pace is, and that's the only way you're really going to be able to do your flow rate testing to make sure you're getting the right millage down. Usually it's about 15 mils wet. Depends on if you're doing a high build, then you get into a 22 mils or something. That may be a little more technical than you want to hear. So I hope that answers your question. Do we have any more?
Yeah, Justin, I'll just add real quick. We go over this in the symposium, but there are resources available on our website. There's the Airfield Marketing Handbook that actually covers some of the calibration process. Calibrating equipment doesn't matter if it's a small machine or a truck. But Greg mentioned the mill thickness. We also do a bead calibration test. So if you have multiple guns, you calibrate multiple. FAA just recently added this control strip language that's pretty awesome. We're not going to take all the credit for it. They actually had to, put it in there, but that was one of our big wish list items that we talked about them a couple years ago. And basically this control strip is after you calibrate the equipment, then you go out, you paint this control strip, you then wait and you go out at night and you do a visual inspection at night with the contractor, with all the stakeholders, and you say, yep, this is good. And then you come back and you paint, and you consistently, routinely check distribution, embedment, things like that as they're painting. That's my process when I do QC. It pretty much requires somebody to be there in that role almost exclusively. Sometimes consultant engineers will have a construction manager that's looking at a lot of different things, and it can be one of many things that they're trying to pay attention to. Just as long as they are getting over there to check on that quality, that's a good practice.
And Mike, we had a question on what is the proper overlap. I'm going to base that on the architectural tip. The manufacturer usually recommends a 50% overlap. That sounds tremendous because you've got 50% on each side, but it does that's what the recommendation usually is a 50% overlap. So that's going to make sure that you get the most even spray. And again, that's architectural. I wouldn't, when you overlap a line striping tip, you're going to have that thick edge is going to be created. So again, if you're doing anything, when we do stencils on the roadway, for instance, we should switch over to the architectural, or in Graco's words, in Graco's style, it's a black tip rather than a yellow tip. So that we can do that overlapping without having these lines across our stencils. So 50% overlap is what you're looking for. And by the way, just so that people know that corrugation is really difficult to completely eliminate. So if there's any of the FAA guys on here, that is a real difficult thing to get completely rid of. But the problem is that if it gets too thin on the edges, you're going to have that problem where you're going to have beads. They're going to be sticking in. They're going to be settling in and embedding in the middle of the marking, but yet not on the edges of the marking. So what looks like a 12-inch line at night is going to look like an 8-inch line. And that's a real big issue. So that's why it's important to make sure you have the right tip. In that case, if it's 12-inch line, I'm using a line striping tip because I want the same thickness all the way across the line.
Yeah, I would agree with most of what you said. I don't recommend the use of black tips, the architectural tips at all. And I would stick with the line laser tips or the LL tips, that yellow tip you see at the bottom there. It is designed specifically for horizontal pavement markings. That's what I would go with, particularly for bead embedment. But if you have, the only time I could see possibly using a black tip would be in the middle of like a 6-gun application where you're doing 3 feet wide. So maybe you have line striping tips on the outside to get your millage towards the edges of that marking, but perhaps you're trying to feather the inside. However, that's a trick. I mean, we're talking in 201 here. We're talking about an advanced course in pavement marking. With the line striping tips, if you only have, let's say you have a 6-gun carriage on a truck, contractor, in-house crew, whatever, and you have 6 line striping tips, I'm going to try to, if I'm doing quality control and setting up this contractor for a quality control strip, I'm looking for a 1/4 inch to a 1/2 inch overlap. That bead of paint gets pretty thick even with just a real small overlap. But that is required because if you don't have an overlap, you have a gap, and that is the worst of the 2 evils.
All right, so we'll meet somewhere in the middle on that one. Again, this is interesting. Two professionals from 2 different areas, but I do agree that on the edges I would put the line striping tip, but I would put black tips in the middle, or architectural tips in the middle, so that you have that overlap fan. But very good. It's good to get feedback from different angles, different views. So very good. Any other questions?
Has anyone?
Hang on. Go ahead.
Type 3 beads experienced a washout, i.e. yellow washing out to white?
The question is has anyone had an issue with type 3 beads washing out the yellow? Yeah, I can say that is mostly caused because there's not a good intimate connection between the bead and the yellow paint. It's a pigment issue potentially with the paint, or this is in my experience, or the bead is too high, which is again pretty darn common out there because the paint's not being put down thick enough. So it's either paint quality or the bead embedment issue. Would you agree with that, Mike?
I would, yeah, Guy, that's a great question. I will add that it is not specific to type 3 beads. This is something that is not specific to material. So, not specific to bead type. So I've seen red signs look pink and yellow markings look white with type 1. Some of the pictures that Greg's pulling up here in the color or the uniformity color failure position here said, that Bravo 1 directional sign is a great example of type 3 glass embedded well. This is an application issue. So just as Greg said, when they're under embedded, they very often tend to reflect light rather than the color of the coating because they're not embedded in that coating. So just like Greg said, he hit it, he nailed it. When the application is a little too fast, paint's too thin, beads are sitting on top and reflect a color other than what it is.
Yeah, I want to show, this is this image here, far left, that one right there. That is a great example of, you see how white it is in the middle. Now this is a daytime flash on this line. These beads are setting high, number one. Number two is they're not dispersed all the way across the line. So this is definitely, sometimes we look at it and we do the sun over shoulder routine, which is really good. That's one of the methods we promote. But you also have to, it'd be a good chance to see if your line is looking. Now remember, you've got an intense amount of light from the sun, so it will seem to whiten it up a little bit. But you're looking for reflectance of color as well as reflectivity, because a lot of people see that massive reflection. Again, sometimes that your beads are probably high in this particular case, for example. So very interesting. Any other questions?
No.
Okay. Well, fantastic, guys. Looks like we held on to quite a few all the way through the last question. So I'm glad we were able to help and assist. And if we can be of any more assistance to you in any way, either one of us, we greatly would appreciate being contacted on it. And God bless, and have a great week.
Thanks, Greg. I'm going to throw my email out there on the chat just in case anybody is interested in sending just a message directly to me. Be happy to answer any other questions.
All right, very good. We'll do the same. We'll put it out there. And again, we will be sending out a survey, so please fill that out. Have a great day. Thank you, Mike. I appreciate it. Great job.
Thanks, Greg. Appreciate it.
Mm-hmm. Bye-bye.
Take care, everyone.